Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In polar protic solvents, nucleophilicity is governed by two main factors, 1. Polarizability of the nucleophilic atom, and 2. Resonance stabilization, delocalization, of the lone pair, which reduces nucleophilicity. Step 1. Identify the nucleophilic atoms and their environments. Species 1CH3CH2CH2O, propoxide ion, nucleophilic atom is oxygen, a localized carbanion-like alkoxide with concentrated negative charge. Species 2CH3CH2CH2S, propenthiolate ion, nucleophilic atom is sulfur, which is in the third period and is much more polarizable than oxygen. Species 3CH3CH2C is equal to O, O-propanoate ion, carboxylate, nucleophilic atom is oxygen, but the negative charge is delocalized over to oxygen atoms via resonance with the carbonyl group. Step 2. Apply polarizability effect, critical in polar protic solvents. In polar protic solvents, larger, more polarizable atoms are better nucleophiles because they are less tightly solvated. Sulfur, third period, is far more polarizable than oxygen, second period. Therefore, species 2CH3CH2CH2S is the best nucleophile. Step 3. Compare the two oxygen nucleophiles. Species 1CH3CH2CH2O has a localized negative charge on one oxygen atom. It is a strong nucleophile. Species 3CH3CH2C is equal to O. O has its negative charge delocalized by resonance over to oxygen atoms. This significantly reduces nucleophilicity. Therefore, 1, 3 in nucleophilicity. Step 4. Compile the ranking. 2, 1, 3, most to least nucleophilic. Step 5. Evaluate the options. A. 3, 1, 2 incorrect, ignores polarizability and resonance effects. B. 2, 3, 1 incorrect, ranks carboxylate above alkoxide, which is wrong. C. 1, 3, 2 incorrect, places sulfur last, ignoring its superior polarizability. D. 2, 1, 3 correct, sulfur nucleophile first, polarizability, then alkoxide, localized charge, then carboxylate, resonance delocalized, least nucleophilic. Therefore, the correct answer is D. Therefore, the correct answer is option D.